Mars' mysterious reflections come from something stranger than water. Scientists hoped it was a lake under the ice, but it may just be a mirage. And this is an image captured by NASA's Mars Reconnaissance Orbiter of layers of ice near the red planet's south pole. Scientists revisiting a mysterious signal from the south pole of Mars have suggested a new potential explanation, and it does not bode well for hopes of finding liquid water on the red planet. In 2018, scientists using data from the European Space Agency's Mars Express Orbiter, Mars Advanced Radar for Subsurface and Ionosphere Sounding, MARSIS for short, instrument announced that they'd observed a radar signal that could be interpreted as evidence of liquid water. That signal, a strange bright reflection, came from the Martian South Pole in a region known as Ultima Scopuli. Researchers investigating the reflection now suggest that the signal did not come from the ice itself or even from the liquid water, but from underlying geological layers made of minerals and frozen carbon dioxide. In particular, it turned out that the thickness of these layers, rather than what they're made of, creates the otherworldly reflection. On Earth, dazzling reflections like this often come from liquid water. For example, subglacial lakes like Antarctica's Lake Vostok, which has been lying under more than 2 miles or 3 kilometers of ice for millions of years, causes a bright radar signal like that found on Mars. However, just because it's possible for something like this to have also occurred on Mars does not guarantee the presence of liquid water. The research team used radar data from MARSIS along with computer simulations to investigate the mystery. The scientists simulated layers of ice and other substances like basalt rock that formed after ancient volcanic eruptions on Mars to see how these materials would react to incoming light. Because there is an immense amount of carbon dioxide frozen in the Martian South Pole, Cornell University planetary scientist and lead author of the research, Dan Lalich, was sure to include layers of this ice in the simulations, and one simulation in particular with a layer of carbon dioxide ice and below the water ice revealed that the separation and thickness of layers determined the strength of a reflection. Previous studies Lalich worked on also found that certain minerals could also conjure a reflection like this. He believes that even layers of the red planet's dust-obscured ice are capable of it. Either way, no liquid water is necessary to create the reflection. I could have used rock layers or even particularly dusty water ice, and I could have gotten similar results, he said in a statement. The point of this paper is really that the composition of the basalt layers, the basal layers, is less important than the layer thickness and separations. The new research does not mean that there is no chance of liquid water existing somewhere on Mars, though. None of the work we've done, Lalich said, disproves the possible existence of liquid water down there. We just think the interference hypothesis is more consistent than other observations. I'm not sure anything short of a drill could prove either side of this debate definitively right or wrong. So in other words, unless you get proper evidence that there's water there, there's no way for them to find out. Now, whether under a glacier or deep beneath the planet's scorched reddish surface water and possibly traces of life, or may still be lurking somewhere. This research describing the paper is published September 28th in Nature Astronomy, and it's on space.com. So they still have not found water. That's the conclusion. And they probably won't know the exact consistency of what they find unless they go and drill for it. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.